So evaluation of the double integral 0 to 1, 0 to root x, xy dy dx by changing the order of integration. So if you want to change that, the given order is now dy dx, means first we have to integrate with respect to y, then with respect to x. Changing the order means we have to first integrate with respect to x, then with respect to y. That means inside limit must be the limit of y and the outside limit must be the limit of inside limit must be the limit of x, outside limit must be the limit of y. So the given limits are, outside limit is x equal to 0 to x equal to 1, and the inside limits are the values of y is equal to x to y is equal to root x. That means as x varies from x equal to 0 to x equal to 1, y varies from y is equal to x to y is equal to root x. So y is equal to root x can be written as y square equal to x. If you square on both sides, you will find y square is equal to x. Y square equal to x represent a parabola. Let us draw all these curves in the xy plane. So this is x-axis and this one is y-axis, mutually perpendicular to each other. X equal to 0 is the y-axis, equation of y-axis, that is x equal to 0 is this line, that is y-axis, and x equal to 1 is the ordinate parallel to y-axis at a distance of 1 unit. So that means x equal to 1 here. So x is 1, y is 0 here. Y value is fixed, that is 0. Sorry, x value is fixed and y varies. X value is fixed, that fixed x value is x equal to 1. Therefore, this is the ordinate parallel to x-axis. Then y is equal to x, as x varies from 0 to 1. If you see the outer limit, this is also called as outer limit, that is constant limit. X is 0 here if you see from the outside, and y is x is 1 here. X is 0, x is 1 here. Then as x varies from 0 to 1, y varies from this curve to this curve inside the region, that is the inside limit, inner limit. So that means you must draw a strip here which is parallel to y-axis to take that limit. What is given here is y varies from y is equal to x, that is the equation of this line, y is equal to x, where the x and y coordinates are equal, to y is equal to root x, means y square equal to x, that is a parabola symmetric about x-axis. Symmetric about x-axis. When you substitute x equal to 1 here, when x is 1, the y value is plus or minus 1, because y square equal to 1 means y is plus or minus 1. So plus 1 is here, minus 1 is in the opposite side, as the parabola is symmetric about x-axis. So therefore the point of intersection is x value is 1, y value is also 1. So this is the coordinate of this point of intersection. So from this we come to know that the region of integration is bounded by this line and this curve between x equal to 0 to x equal to 1 according to the given integration. Let us change the order. If you want to change the order, we have to take the constant limit along y-axis. That means outer limit must be the limits of y. So if you look at the region from the outside, y varies from this line, the equation of this line is y is equal to 0 to y is equal to this line, the y is equal to 1. So y equal to 0 to y is equal to 1. As y varies from y equal to 0 to y equal to 1, then inside the region draw a parallel strip to x-axis, and this point lies on this curve, that is the lower limit along x-axis. Start from this curve. So the equation of this curve is x equal to y square. Therefore x varies from x equal to y square to upper limit lies on this line, and equation of this line is x equal to y. So therefore x equal to y. So lower limit lies on this curve and the upper limit lies on the curve x equal to y. Therefore, x varies from x equal to y square to x equal to y. Therefore, this integral, which is 0 to 1, x to root x, xy, the order is dy dx, can be written as 0 to 1, that means the limits of y, outside limit 0 to 1, then inside limit is y square to y. X varies from y square to y, then the function is xy, the order now is dx dy, first with respect to x, then with respect to y. Let us integrate this integration. Let us integrate this function with respect to x between the limit y square to y. When you integrate with respect to x, you can see that we have a variable y. You must treat it as a constant. So y is like a constant. Then integration of x is, with respect to x, is x square by 2. Then substitute the limit, upper and lower limit. Upper limit is x is equal to y and lower limit is x is equal to y square. If you substitute the upper limit to y here, you will find this y, and this 1 by 2 I wrote outside, 1 by 2. So this y is here. So substitute y here inside the bracket. You write it as y square minus, because 2 I wrote outside, then you have to substitute in place of x y square minus, substitute y square in place of x, y square whole square is y power 4 into dy, which is equal to half 0 to 1, y into y square is y cube minus y into y power 4 is y power 5. Add the powers, 1 plus 2 is 3, 1 plus 4 is 5 into dy. Let us integrate y cube and y power 5 with respect to y. So this integral becomes 1 divided by 2 y power 4 by 4, integration of y cube is y power 4 by 4 minus integration of y power 5 is y power 6 by 6 between the limits 0 to 1. So 1 by 2, then if you substitute the upper limit in place of y, you will find 1 by 4, and here if you substitute 1, we will get 1 by 6, which is equal to 1 by 2 bracket 4 6 are 24, 6 1s are 6 minus 4 1s are 4, 6 minus 4 is 2, so 2 by 24. If you take the LCM, you will find this 2 by 24. So cancel this 2, which is equal to, the answer is 1 by 24.